So again, remember that you're going to have quiz the next day you're coming in, and the quiz that you have on Friday, which means, no, Thursday, so Tuesday you're going to receive the description of the question so you can work on it and be ready on it for it on Thursday. We have an integer array over here that is kind of created to simulate an array better than we had in OOP244. Sorry for the delay in talking. I'm looking for the light switch over here to reduce the light in here, but I can't. Anyways, look at the, the screen is okay. Is it visible? Yes.
Why is there a virtual destructor?
First of all, that's virtual destructor is a must. You need to like obsessively make every destructor you create virtual. Why? In case of inheritance.
But you're not inheriting here.
Pardon me?
But you're not doing inheritance, right?
Do you know you're going to do it 3 years from now? No. It's one keyword that you write that makes your code safe forever. So if there is any chance for a class to be inherited to something else, you must make it a virtual. Why? Because if you have a pointer of a base pointing to a derived class and you delete it, then you're going to have memory leak. We have to do everything we can to prevent it. So in my class, you are always writing a destructor as virtual. If you miss the virtual, you lose mark. Okay, just to enforce that, that is extremely important. So always make it virtual, and thank you for the question. Always make it virtual to make sure if there is some kind of inheritance someday, things are not going to go bad. So as you see, this is for OOP244, and what it does essentially here, it creates an integer array that is an automatic type of an array. Essentially, in this array, you can do stuff like this. So I can actually, let me just first include that. So I'm going to go include int array, and using namespace Seneca. So now what I'm going to do is this. I can actually create an integer array. Say this is an int array, AR, let's say, and I'm going to put over here. I'm going to create here 5. So this is going to be an array of 5 integers. Okay. I can write something like for integer I set to 0, I less than 5, and I plus plus. And I can set ARI to be, say, I plus 10. So essentially put 10 up to 40 in there. Now, my array is pretty cool. I can literally print the array like this, AR, and it's going to show a comma-separated array for me automatically. So when I do something like this, they can actually see the content of the array. Take a look. Come on, today. There we go. So as you see, it actually shows the array comma-separated. Not only that, it is a smart array, which means if I have it 5, and by mistake over here, I put 10, no matter. It's going to resize itself to the size that it is and expands itself so it can actually have everything. So now it's 10. I can like literally use it freely without worrying that the size that I have is not what I want. It resizes itself automatically. Now, how does this thing work? It is from OOP244, but I'm going to walk through it to kind of remind you what it is. So the description of what is being done over here. Int array is specifically done for int. And I'm going to make it 345 because it's OOP244. I have over here size as an integer, which is a wrong thing to do. Size is something that is never negative. Is this mine? I'm so sorry.
It's fine.
All right. So size is something that is never negative, and we have a specific type in C++ built in for that. What is the specific size? What is the specific type that we have? Size unsigned int, that's C, not C++. In C++, we call it size t. So instead of an integer over here, I can actually write size t. Not to worry if it's negative or positive or something like that. So I can, let's see if it works. I have some problem with my computers. For some reason, the control key is not working. And my Visual Studio is going to behave badly because it's out of date, and I just got the message that this version is not supported anymore. This computer is Seneca, so I cannot install it myself. I have to ask IT to do it, and they're outside. Okay. So that's why you see some stuff are happening over here. My apologies on that. So yeah, so in here, I'm going to, let me just copy it manually. Control C doesn't work for some reason on this. Now I'm going to go Control V. There you go. Oh, no, it didn't work. Control copy. There we go. So that's size t. And over here I have a function called resize. So what resize does is a very simple thing. It does what we learned to do in OOP345, which was dynamic resizing using dynamic memory allocation. So any size that I put in there, it's going to resize the array to that. So if my array is 5 and I put 10 over there, what it does, it first allocates 10 integers. Then it copies the 5 integers into it. Then deletes the old ones and sets the other one to new one. I'll show you the code. The int array is the constructor. So in a constructor, I can tell how many integers I want. And the size, and this one is intelligent one, so I can actually tell how many I have. So size t, size tells me what is the size of the array. Unlike regular arrays in C language that are not aware of their sizes, this one is. Anywhere you send it, it knows where the size is. I have overloaded the subscription operator, the index operator, to give me the reference of element of the index that I want. And it's an automatic one. So if the index is within the range of the size, it's going to return the reference. If it's not, it's going to resize and then send it. So even if you exceed the size, it's going to expand itself automatically. And I'm passing its size index. But this is where because as you see, it's not constant, it only works if the object is read-write. It's not a constant. To make this thing work, if a constant reference of the object array is passed somewhere, I overloaded the index operator with constant integer reference, and obviously in here I'm going to put a size t for that. Okay? I have a virtual destructor. We explained it's a very good practice to make all your destructors virtual in case you do inheritance. Nothing's going to go wrong with it. And now let's take a look at the C++ code for this, and we're going to fix it to match what we have created over here. So let me put this thing up here so I can actually. So I'm going to split the window in two and make it small like that. Bring this at. So on the right side, I have the header file, and the left side, I have what I want to fix. So first of all, the constructor over here is changed to size t, so I'll make it size t. In here, I'm saying if size is less than or equal to 0, make it 1. It cannot be less than anymore because it's size t, so I'm just going to check it for equality. So if somebody creates they give me an array with size of 0, I'm going to ignore what they said. I'm going to make it size of 1. Okay, just to make it foolproof. Then I'm going to do a copy constructor. I'm going to say, okay, in copy constructor, I am creating new integers. That's fine. And I loop through all the stuff. Oh, and it's a copy constructor. I create an integer to the size of the one that I'm copying, and then I'm going to go through one by one and copy the data. But because m size is size t, the index of the loop should be size t2. For assignment operator, same thing. So I'm going to say if I'm going to create the values. Of course, it's going to be deleted first, and then it's going to get the size, copy everything from the other one, and then return the values. We learned about move constructors and move assignments, so let's add those two. So I want this array to be able to be moving to another array if I want to. So how do I do that? For the constructor, a copy constructor is very simple. All I need to do over here is to say int array. And I'm going to say int array. I'm going to call it MV for the one that is moving. And I'm going to create the code for it. So create the definition. It comes over here. The difference over here is that now the difference between this one and the copy constructor is that I'm not going to allocate anything new. I'm just going to say, hey, whatever I have over here, my data is going to point to the other guy's data. So I essentially point to that one, and I'm going to say my size will be equal to the size, will be set to the size of the other one. And now that I am pointing to the data of the other object, I'm going to tell to the object that you don't have anything. So the moves m data will be null PTR. And my size, the other one's size. Size will be 0. Okay? So that's moving, which means no copying is happening. I'm just taking over the other one. And right over here, you see how much time we saved. I'm not doing any dynamic memory allocation. I'm not looping through any data. All I'm doing is pointing to the other object's data and setting that object to null. Essentially, everything is moved over here. And we learned that we're going to write over here no exception. And I forgot to write. We're going to find out what it means at close to the end of the semester when we are talking about exception handling. For now, if you don't write no exception, I'm not going to be very mad. Okay? So that's that. So we are good down to this point. And creating a move constructor is the move assignment is the same. So I'm just going to essentially copy the exact same thing. And just remove this thing and make it non-constant, and R value reference with a no exception over here, and then ask for its implementation, which is essentially the exact same thing that we have in here. So exactly what you do in a regular one. The difference is that the action of memory allocation is changed with the moving. That's the only difference. Oh, CP, sorry. Move. So I'll make sure that I'm not doing self-assignment. Then I'm going to say delete the data of me. make me point to the data of the other, and set the data of the other to null. It simply takes over. So that's essentially that. Now let's continue. This size returns size t. Over here, the operator receives size t as an index. It is impossible to be negative, so this if statement is moot. We don't need it. And over here again, the integer over here is size t, and there is no need to check to see if it's negative or not. As you see, when the object is read-write, I get the index. If the index is exceeding the size, I resize it, but at the end I just return the reference of the element. But when I am in read-only mode, if they exceed the size but an index, I'm just going to return the modulus of index by size. Therefore, it loops back on itself. If it grows, it goes. So if it's 5 and it becomes 4, 4 mod 5 is 4. If they put 5, 5 mod 5 is 0. It goes back in. 6 mod 5 is 1, and it keeps going like that. So the index loops back within the size. No matter what they do, they cannot go out of the size, and therefore no crash. For display, no array has this thing. I just did it for fun for some reason. It's just, I'm saying if you display the array, it's going to show it comma separated, so that's what I'm doing in here. So essentially, I'm saying show the first one, and then start from the 1 and go up to size, and display them one by one, comma separated, and get out. Okay? Simple and straightforward. For resizing, I should put over here size t, and this one size t2. So I'm essentially saying to create a new array with the new size, copy everything from the old one to the new one, either up to new size or the size, whichever comes first. So if it's like this, I can actually make it smaller too if I want to. Okay? Yes, I can shrink it to what it's never used, but you can. And it just resizes it and deletes the old data, so that's that. And display, overload displays everything. So now I have the array. It works the exact same way, no difference. And that is that. Questions down to this point? Just, yeah.
Can you explain how the move constructor works and how the assignment operator with our value reference works?
So what happens is that when you pass the array with an x value, which is essentially is called an expired value, any value that is about to die, okay? What happens is that it essentially gets the array and passes the new reference of the array to the, let me put it over here so I can show it. So say I want, say I make a copy of, say I do something like this. I don't know why I want to do it, but I'm going to do something like this. So I'm going to say integer I5 or AR5 I want to have I, yeah, and, or even this. So what happens over here is this. it creates an array of 5 integers, right? Then it wants to create the AR to do the same thing. So what happens over here, it says, okay, I want to copy the I over here and put it in AR. So what's going to happen here? Because it's move actually creates an x value out of I. I'm going to explain soon what is x value or R value. And therefore it triggers the copy construction instead of move construction instead of copy construction. It comes in here instead of there. Therefore, AR over here will say my data will be I's data. Therefore, it's going to point to the data of that one. And then when it comes to the size, it receives the size of the other one. After it's done with that, it says, okay, I's data, I am pointing to it, therefore I shouldn't. So it sets the data of I to null and sets the size of I to null. Therefore, that becomes empty. This one becomes full. And which is actually not a right thing to do with my logic. It is perfect. The reason is that it was because it was done for OOP345. I'll explain why I said it's not a right thing to do with my logic. Now that I walked through it, I noticed it. The other class didn't ask for it. And I told you, because I do this on the fly, you're going to see there's a problem in here. See what I'm doing in here? I'm saying if size is 0, do that. You see that? It actually makes the size 1. You see that? So in here, when this happens, it's making it null, which is wrong. You follow what I'm saying? It's supposed to be 1 if there is nothing in it. So to follow my own ruling here, I have to say new int 1 and make the size 1, not empty. Because I said by default an array cannot be empty. It has at least one element. So that's going to be the thing for it. And in here the same. And why am I saying int 1 and not saying no int? Why am I saying int 1 and I'm not just saying int like that? Because I want it to be an array of 1, not just one integer. Then the delete is going to fail. Because my delete always deletes with an array, so I have to create with an array. And for the size now, I'm going to put over here 1. So now it's better. So essentially it says, I'm going to get all the data of the other one, and make one only have one element, which is an empty one type of it. Okay, now it actually fits. Yeah, like that, if I actually printed it, it would have failed because this one doesn't check, that my print doesn't check to see if it's empty or not. It prints the first one. So that would have actually failed. And I have to fix the code for the other class because I didn't do that. Anyway, so that's the moving thingy, which I do not want to focus on right now. That's why I'm going to remove it and go back to what we had before. Okay, my focus is on templates, okay? This only works for an integer array. I don't want that. I want it to be an array of int, array of double, array of employee, array of car, array of anything. For that, I'm going to convert this thing to a template. We said last day that when we talked about template is that unlike regular modules, when you are creating an array, when you are creating a template, it must all exist in a header file of its own. So in here, I'm going to go to header files. I'm going to say add new item, and I'm going to create a header file, and I'm going to call it array.h. So essentially, I'm creating only one array. Pragma once is a shorthand for if not defined, define. But to make it backwards compatible, always add them both. So in here, I'm going to say if not defined, Seneca array underline H. Then I do this, Control C V. And in here, I'm going to make this define. And in here, I'm going to say namespace Seneca There you go. I'm ready to write a program. So I want to convert the other array to a template. So what I need to do is to bring all its source code into header file, CPP and .h. So I'll go and open up the header file first, and I'm just going to bring the class just like this in here. Now, luckily, when I created this, I put std for OStream. Because everything is coming into a header file, you're not allowed to use using statement. So you are including IOStream, obviously, because you want to have input and output with this thing. But because you are not allowed to put using, every single OStream object and class must be qualified using a scope resolution in namespace. You cannot write a using and remove the std because it's a header file. That's the rule. And the reason for it is that if you do that, it becomes hidden logic, which means if anybody includes the array.h, then they're going to start using std when they are not aware of it. Next thing, I'm going to go to array.cpp, and I'm going to copy everything in there, Control C, and I'm going to put it in the header file. Okay, so everything is there. I'm going to just save everything. But before I continue, I'm going to just make sure that everything's good, because did we test it after changing it to size T to see if it works? Let me see. I want to make sure that everything's good before I continue. I don't want something with syntax error to come in. Give me a second. I just wanted to run, make sure everything's good. Yeah, it's good. Okay, so we're good. All right. So now that I have everything in array.h, I'm going to remove these two. So the very end, let's call this one int array main. So I'm going to call int array okay. Very first thing I'm going to do, I'm going to change the class name because it's not an integer array anymore. It's supposed to be array of everything. So I'm going to just check that one, Control H, and say change int array to array. Replace all. So it's going to change the whole thing. It's going to change just the name of the class to an array. We good down to this point? Okay. Now, we'll start converting it to a template. First thing first. First thing that we're going to do is to add the template. Type name, type.
Why not T?
Pardon me?
I thought T was the convention or something.
Sure, you want T? I can put T. But type, because it says type, it's better to know. You can put anything you want. Either T, type, whatever. It doesn't matter. Anything you want. Okay? I'm going to put type because I'm going to keep talking about type. I wanted to say type. Okay? Other than that, sure, use T. Anything you feel is good for the template's placeholder. This is the placeholder for the type. That's why I'm calling it type. And you have to add this to every single scope of this template. So, so number one, to convert to a template, number one, add the template statement to every single scope in the code. Okay, so I'm just going to copy this because I'm going to add it. I'm just going to add everything to Control C. Okay, so that's the first. So the scope ends over here at line 30, right? And now it's a single line scope, so that needs a template of its own. Then I have, this is another scope. I'll add it to this one, every single one. And the two of them don't need to be typed. This one can be typed, this one can be T, the other one can be whatever you type. But don't put everything else as the same thing. Okay, so Control V. So that's step one. It seems like it's a repetitive thing to do and a boring thing to do, but when I do it over and over, it's as if somebody's repeating for you. And because you keep saying, come on, do it, be quicker, that actually fits in your brain and you're going to remember it later on. So essentially, coding in class forces me to slow down and forces you to digest what I'm saying. So it's a twofold, okay? So the template is added to all the scopes. Let's double check. Scope, 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 scope. Everything's added. Fantastic. Then that was number 1. Number 2, you convert all the focus type of a template to the type. So focus type of the array is the elements type, correct? So that has to change, and it's an integer over here. So instead of integer pointer to an m data, that should be a type pointer, because if it's an array, array of doubles, it should be an m data of double. If it's a car, it should be an m data of cars. So all these things should change to type. So that's that. And down to here, I don't have anything. Size is size. It has not. Oh, there we go. It's returning an element, so it has to be of type. I don't know what the heck happened. My Control C doesn't work for some reason. So copy. Type. Control C. Let's see if it works. Type again. Yes. Okay. So type. So this one returns a type. This one returns a type. And the rest seem to be okay. In here, I am creating an array of ints. It's supposed to be array of types. Down here, array of types. Down here, a single integer, so that should be a type. In here is, again, type. A single integer, it's a single type. This returns a type. This returns a type. This is a type pointer temp that points to a new array of types, which is fine. This was supposed to be size t. I forgot to change it. Okay. And we are good. So number 2, the focus type of the object should change to the of the template. Templated object or class should be changed to the type of the template. Okay? That's number 2. And number 3 is the most important one. All the class names, templated class names, should carry the signature of the template, which is essentially type. It should be added to it. And I'll explain why. We talked about class templates. We said class templates don't have signature, right? Like a function that we add templates for that we wanted to call a function, it could find out which function to create because of the signature. So we said for a class, we have to add the signature to the name of the class. Okay? For this, we have to do the same thing in the templates itself with 3 exceptions. Except the following. The name of the the name of the class right after the template. Statement. So this should not carry the signature. Why? Because this is the name of the class. I'm essentially saying this class is supposed to be a template, so that doesn't need to have the signature. Number 2, special functions, special procedures. Constructors, the constructor names the constructor names should not take the signature, because constructor names are not classes to get instantiated. They are essentially telling what the procedure is. So that remains the same. And finally, the destructor. Other than these, everything should carry the type signature. So essentially, I need to look and see what do we have. So this is fine. It's after template nothing. It comes over here. This is the name of the constructor. No, I'm not going to add anything. This is the name of the constructor. No, but this is just an argument. So it needs to know what type of an array it's copying. Therefore, you must add the signature to it. Same for move constructor. For assignment operator, it returns an object of type array. It needs to know which one and receives an argument. Same thing for here. This is size. This is the destructor. Nothing's going to be going over there because it's a destructor. I'm not going to add anything. But and the rest. So the class declaration is done. Then we go to the overload for the insertion operator. There is an argument for the array. That's going to take the signature. For the constructor's definition, this is the owner. The owner needs to know which one it is, but the constructor remains the same. Same thing over here. Owner takes the signature, name does not, but the argument does. Name doesn't take the signature, the argument does, and the rest remains the same. Again, name takes the signature. Name takes the signature, owner takes the signature, and type takes the signature. They all do. We come down over here. Return type takes the signature, owner takes the signature, argument takes the signature. Owner takes the signature, the destructor will not. Owner takes the signature, owner takes the signature, owner takes the signature, and owner takes the signature, and we come down here. Again, owner takes the signature. In here, it's a standalone function, therefore it's only the argument. And voila, now I have a template for an array. So in my main, now, instead of actually, so first of all, I'm going to over here include array. In here, I'm going to say array int AR5. And I can do the exact same thing, writing double. And I can repeat the code, and let's call this one, say D. And I'm going to copy this. And in here, I'm going to put D and D. Now, if everything goes okay, this should create an array of integers and go through it, and then an array of doubles, go through it, and everything should work. Let me see if there's anything good. We'll find out. We'll execute and see what happens. We'll compile. And, oh, they are both integers. Why? Let me see what we have done wrong. Oh, they are not both integers. This is a double. I should actually add some double things to it. Now it's better. Control F5. Sorry, I just didn't present it properly. There we go. Now I have an array of integer and an array of doubles. And you can have an array of anything with this. So what you see over here right now tells to the compiler to build the exact same class that you created only for integers for whatever you want. And you can do that to any generalized class that you have. Any type of class that can be, that its focus type needs to change to anything else, you can always convert it to an integer, to a template and generalize it. Do we need, like this array, you can really use it for anything you want. It works perfectly. But don't. We have the exact same thing in a standard template library that is written much more efficiently than this one. And it's called an array, literally. We have queues, we have vectors, we have all different types of containers that you have that you can use. And there's absolutely, they absolutely work perfectly, and you'll see it soon. So that was showing how templates work. And the good thing about it is that why do I give this example? Why don't I just go to the standard template library and show you the syntax? It's exactly like using AI. Why are we learning how to program when AI can program anything for us? Okay? The reason is that if you don't know how the things work, you cannot ask the right questions. So say you have a chef of a restaurant that's just the owner of a new restaurant. You think if that guy talks to AI, it can create a program that takes care of orders and things like that, and tell to ChatGPT, I am owning a restaurant, create a program that does everything. It can't. They need to know what to ask and what to ask so the AI can actually create the application for them. They need to know how the programs are written. It's the same thing over here. I'm telling you what happens behind the scene when you are using a template. So when I teach you standard template library, you will know what are the limitations. For example, you have to document this template of yours to see what can it work with. Can I use it for any object? The answer is no. When you are looking at this code, for example, in here, you see it says that mdata is equal to new type. So it essentially creates an array of types, right? Does it initialize to anything? Does it put what value goes in there? No. What does it mean? It means the type must have a default constructor. If it doesn't, your template's not going to work with it. That has to be documented. So at the top of the thing, at the top of your template, you need to actually implement all these things. You actually need to say that type must, type of the template, must implement default constructor. Now, whatever that is, we don't care what it is. It must implement default constructor, whatever that default constructor is. And then you keep going. For example, in here, you are setting one type object to another type object. You have to make sure that the assignment operator works for it. It's assignable. And it keeps going over and over and over. So assignment should be set. So that's another thing. I'm not sure that I'm actually putting anything. Type of the template must implement copy assignment. So that's extremely important. I don't know other stuff. Go through it and see. So and see if there is anything else is needed somewhere in here. But the only thing that I can see over here is that I am printing the type on O stream. So the last thing is that the type must be insertable into O stream. So when a person uses your template, knows what type of a thing they can use this array. All right? That's that. So that's the templates. Now, we're going to quickly go through the expressions and understand what expressions are. And after that, an example for composition and those relationships, and then we're going to call it a day. So talking about expressions, like why do we need expressions? Because they are building blocks of C++. Expressions are extremely important. Although an expression works with operator and operand. So essentially you have A plus B. This is an expression. B and A are operands. Plus is the operator. And it always returns a value. Always. An operator always returns a value. Most of the bugs that happen in programming when you're a rookie is that you don't know which operator has precedence over the other one. Which one runs first? When you write 2 plus 3 multiplied by 5, plus it comes first, you know that multiplication happens first. Therefore, you know. So in an expression, you need to know the precedence of all the good stuff that you have. So, and also we need to understand what values are. So what I did, I actually put this thing that I'm using for teaching for you. So you can exactly see what it is. So it's an MD file that is in your thing. An expression has two parts, a GL value, okay? And GL value is a generalized value that you have and an R value. Generalized value can be an L value or it can be a PR value. But X value is the tricky one that can stand in both ways. And after the expression is done, X value turns to an L value, always. So during the expression, X is an expirable value, a value, temporary value that will die after the expression is done. Okay? So an example for it, very quickly. It's very confusing, but this is L value, this is R value. We know that there's no problem. X plus 5. The result of the plus is an expirable value. It expires and then goes to an L value. Okay? But it expires afterwards. It copies and expires afterwards. It is a PR value because it doesn't have any memory located for it. You cannot say where the plus X plus 5 in the memory. When you write X plus 5 and put it into an R value reference, it materializes into an X value. So during the execution of the expression, that temporary value will not die after, but it will actually be referred to as Z. But after it's done, that Z is an L value. Don't get confused with the double ampersands that you put over here for a reference. Single reference or double reference over here, they are both references. No difference. The only difference is that when you put an R value reference, it detects what's coming in. That's all. It's just for overload matching. That's all. Okay? And that is it. The operator precedence, which one comes first, which one comes next. Please, and the example is a kindergarten example that you have in IPC 144. It's here. I'm not going to go through it, but the lists are all over here. So whenever in doubt, go through this list and see which one comes first, which one comes next, and so on and so forth. Examples for it. One by one, I'm going to give you examples of each line that we have. The subscription operator. You know what it is, index, okay? Member selection, either dot or arrow. Dot goes with a reference, arrow goes with a pointer. Member value. Increment and decrement, you know that, but a postfix one. That's the exception. Everything is, all the expressions that you have are math expressions except this one. In math, we don't have anything that comes after an operand. That's the only one. And that's why when you are actually overloading it, you have to overload it in an awkward way. Add an int to the argument list just to make sure it identifies as a postfix operator, but that int doesn't mean anything. That's the one, okay? Prefix expressions are normal. You know how it is and how they get overloaded. There's no problem with that. Unary expressions, size of is an overload. It's not a function. It's multi-letter, but it's like -5, +5. Size of is that. Logical, unary operator. Address of and in direction, so the address of X and target of P. So these are the two unary overloads. Do not use C++. Do not use legacy casting anymore. All your casting is supposed to be done through what should we call it? The C++ style cast, which is templated cast. Please do so. What is the difference between templated cast and a legacy cast? Legacy cast doesn't give you any error if you do casting in a wrong way. In here, you have 4 different types of cast, and when you mention what you want to cast, you have to do that. So when you are doing a reinterpret cast, the 2 things must have a different type. Otherwise, it won't allow it to you. When you are doing a dynamic cast, the pointer must be convertible to a child. Otherwise, it will fail and return null. So it just makes it safe. That's all. So you just mention what you want, and it does it for you exactly. Binary expressions, they get two operands and return a value. You know exactly what they are. Relationals work like this. It's exactly like binary. It just returns true and false. Short-circuiting. Short-circuiting is for works like this. I don't know what that thing was, a flash over there, but works like this. So let me just, again, I apologize for, I always do that for lack of artistic talent, but let's assume this is a light bulb. You can go on and off. Okay, now this light bulb goes here and gets connected to a switch and to another switch. And then we have a battery, and battery goes to the other side of the light bulb. So if these 2 things are closed, the circuit circulates and light goes on, right? Now, we have 2 switches over here, switch A and switch B. My question is, if switch A is off, does it matter what is the state of switch B? No, it's off. The light's going to go off. That's what a short circuit is. I'm saying if I is not equal to 0, I is 0, okay? So this is false. Because it's false, the second one will not happen. It won't even get checked. And this is a very important thing in computer programming, especially if you want to write programs that are very quick. So quick program like, I'll explain it to you in a second. Oh, shoot, it started a new one. Anyways, I wanted this one. Let me close that. So if I bring this one up, say say I have a size, like I have a million integers over there, okay? Then I do something and I set those values to something, right? You okay down to this point? Now I want to find out how many of those values are negative. A normal way of going through this is to go for size ti set to 0, I less than a size, I plus plus, and have a counter. Size t negatives, okay? And then right over here, if ai is less than 0, then you go negatives plus plus, right? And then you have all the numbers. We good? Now let's walk through this. It comes over here. If, so the if comes over here and checks. Is this less than 0? No, it's not. It does a go to. It jumps to, so it has to skip this operation. So essentially tells to the CPU, hey, don't continue to the next statement, jump to the next one. Jump to the next one. So it has to check the condition and do a jump right after. And that's lots of work. Okay? You will see many if you actually do start hacking professional C++ code, nobody writes something like this. If you want to actually do something like this, the proper code is this. Done. So I'm not going to write an if statement anymore. What I'm going to write over here is an expression. If this thing goes true, then with and, if this thing is true, to see if the light's going to go on or off, it should check the condition of B. Therefore, it evaluates that. Therefore, negative will be added by 1. It doesn't matter what the outcome is. We don't care. The second time comes over there. If this is not negative, it's false, right? Because it's false, the second part will not get even evaluated. Therefore, it's not going to be added by 1. And this runs much faster than the other one. Okay? So stuff like this happens all the time. Now, this is for and. So if you want to check to see if some condition happens and do something, then and is your friend. But if you want to go the other way, then this is the one. Okay, so we have another light bulb. It comes in here. Goes to the battery. And goes up. That's A, and that's B. Now, if A is true, does it need to check B to see if the light is on or not? No. So that's the short circuit for this. So if you want to see if something is false or not, but if A is false, then it has to check B. So if I want the opposite, if I want to see if falsehood is happening how many times, then you use an or statement instead of and. You're saying condition and whatever. So essentially, I could do this. So exact opposite. So if it's true, that happens. If it's false, this happens. Okay? Are we okay? All right. This actually, it has another name. So it's not only short circuit, we call it lazy evaluation. Okay? So I'm going to say lazy evaluation. That's how I learned it, or short circuit. Okay? Be aware of that. Assignment, you know what it is? A equals B equals C, or A plus equal to. These are all both assignment, but this is, of course, it's a plus equal, but it still does assignment. It does two things, adds and assigns. Side effect, essentially. Comma operator is very weird. You've never heard of it, but if you put comma operator, you can put a comma operator in an if statement if you want to. It's nuts, but you can do it. So essentially what happens is that it happens first, and then this happens. So essentially y becomes 5, and then 2 becomes 7. 7 goes over there. It just does two things at the same time. Ternary expression. Ternary expressions, you know about it. You've learned about it in IPC 144. The only thing that I don't think they put enough emphasis on it is that the first and the second must have same type. If you have two different types, it's not going to compile. And that's that. And that's break. We'll go for a break. We'll come back. We'll take a look at the three relationships, and then we go home. So please remind me to resume recording. Okay, so as I was saying, association is when the two objects in relation, they are aware of each other, they use each other's features, and they send messages to each other, but they exist independently, and they get created on their own logic, and they die on their own logic. So it doesn't matter. When one dies, the other one exists, and so on and so forth. So let me bring up the code for it. Give me a second. All right. Association. The example we gave, teacher and student. Look at the student. Student is a class. It has a name, and you can set its name using a constructor. When you look at the teacher, teacher has a name of its own, but then it has an array of 45 student pointers. That means teacher have access to the students. It's a knowledge of whatever it is. So when you create a teacher, no student is created whatsoever. When you add a student, it's only a pointer of the student that is coming in. It means the student must exist outside when you're passing it through. And then it adds that pointer to the teacher. So teacher is aware of the student out there, but they have nothing to do with each other with respect of lifetime. So as you see in the main, we have OOP345, we have Marcus in our class, and I say Farda is new teacher, and it adds Marcus to the class. But when I delete Farda over here, Marcus stays. It has nothing to do with Marcus and everything. This is association. When one class has pointers to the other class, and they are aware of each other. With aggregation, it's a bit different. with aggregation, the container object, the object that has references to a group of other objects or a single one, it doesn't matter, it creates a copy of an object outside in itself. So the object exists outside. It doesn't have a pointer to that object, but it copies that object into itself and then manages that. So when the aggregator is gone, the copies inside the aggregator will be deleted, but the originals still exist outside. That was the library and book example. So as you see, book is outside. It has its own whatever it is. And when you're adding a book, the reference of the book in a constant one is received, which means it cannot change the contents of the book outside, but it will create a new instance of the book, copying the book outside and keeping the address in here as dynamic stuff. So whatever it wants, it can do to the book. The library can stamp the book, it can write, it can change the label, it can put whatever it wants on it. But after the library is closed, all the books will go with the library. The books outside won't change. And a copy of the same book can be in 50 different libraries. You okay? You're okay? And obviously, when the library dies, all the books are deleted. Composition, however, works a bit different. The classes that are composed cannot be created on their own. In this example that I gave you in class, actually said room and a house. The room doesn't even have a public constructor. You cannot even instantiate a room by itself. What you do, you give access to house to access the room if it wants. So a house can build a room, but the room cannot be created on its own. Therefore, when you are building a house, you make the house, put the address, whatever you have, but when you are adding a room, you give the material the house needs to build a room out of. So I'm simply saying add room, I give it the room name. It uses the room name to call the constructor of room. Why? Because it's a friend of the house. It can actually construct it. It constructs the room, adds the room one by one to itself, and now we have our house full of rooms. When the house is demolished and it's gone, it deletes every single room. Rooms exist in the house, but not outside. And that's composition. Are we okay? Are we okay with this? Now in here, just for fun of it, I am adding an existing project, another implementation, and I'm calling it aggregation, which is wrong. What I want you to do, I want you to look at this code, and in your reflection for your assignment, what you have, explain to me, what do you think this thing that I'm calling act? So I'm going to say, I'm going to say, what is this? What relation? That's the name of the project. Let me set it as startup project. Set as startup project. Now take a look. So this is the class diagram of what I've created. Quite frankly, first I wanted to do this as an assignment for students, but then it came a little too complicated, so I said, the heck with it, I'm just going to give it as an example. So IOAble is class is an interface. It means anything inherited from it can be displayed or read from the screen. title is IOable, book is IOable, library is IOable, okay? And now I have something called hide subcontent. That is a manipulator, like the manipulators that you use in cout. You say cout left A 5 and it left justified. You say right it right. So it manipulates display of a library and a book on a screen. This is IOable. Oh, not this. I'm not going to go through it. I'm just going to quickly tell you what they are. You go home, walk through it step by step and see how it works. So it displays, an IOable can display itself, read itself, and it can hide its own subcontent if needed. Why did I do that? Because I was creating a relation between a library and a book. And I wanted to be able to display the library. So when you display a library, that library should show the books that it has. So when I display the library, it shows the title of the library and it displays the books. Books work the same way too. When you display a book, it should show the book and show which libraries you can find this book in. The problem was, if I did not have this hide subcontent, it would be a chicken and an egg problem, which means I would show the library would show the book would show the library that the book exists in, the library would show the book and it would go forever. So at any moment when library was shown, I should hide the subcontent of book. And when the book is displayed, I should hide the subcontent of it. And that's the reason I had that one. So this is my manipulator. So what it has, first of all, it shows what it's where it's manipulating it. So it needs to know what type of an O stream it's manipulating it into. If you don't mention, it's going to be cout, but you can manipulate it into a OF stream if you want to. It sets its own OS to whatever it's needed and returns the reference of hide subcontent. You can insert this, insert an IOable into this hide subcontent. So you can essentially say that's how you can actually manipulate it, which essentially means this. So essentially you can have something like cout hide whatever subcontent, whatever that. So the name is this hide next subcontent. That's the name. So you should be you can do something like this. So an object so you can have an object of book inserted into the manipulator and then go to cout. Therefore, when the book is printed, it's not going to show which thing is coming up. So that's the manipulator. And obviously, it needs to, the manipulator itself should be able to get inserted into cout, and that's what it does. Okay? Now, what is a book? A book has title. It has ISBN. It has an array of pointers. So when you see two asterisks, don't get scared. It's a pointer to a pointer. Essentially, it means it holds address of a dynamic array of pointers to libraries. So it's an array, two-dimensional array, essentially. It tells you how many libraries, and it tells you if it's, and it actually holds a flag to know if it's going to hide the next print or not. And literally finds a library inside the thing. It doesn't matter. So you can create a book. I don't want the book to get deleted or copied, so that's what I did. I just wanted to make it simple. You can add a library, okay, to a book, which means which library it exists in, and you can, and it returns a Boolean when you do that. So both work. You can add or do this. They're both the same. This one returns a book. This one returns a Boolean. Hide subcontent. When you call this, it's gonna literally set this thing to true. Remove removes a library, so it means this book is not in this library anymore. Display displays it, and iStream reads it. Identical thing happens to the library. So the two objects are the same thing because the relationship is the same. Library is an IOL2, it has a title, how many books I have in it, and so on and so forth. It's exactly the same. And the relationship I created for this was here. So as you see, show TP, this P is a since you like T, that's T. Okay, so T is a pointer to an array of an object of a class, okay, or whatever, of a type. Anyways, so I wrote show so I can show whatever I want. So if I put an array of books, it's going to show the book and go to next one. Show it, go to next one until it hits to null. And it actually prints a null terminated array of pointers. Okay? So it one by one prints it until it hits null. So I create libraries. Let me just run it and show it to you. That's easier. So now what I want you to do as practice, go, oh, I'll put it in the wrong place. Okay. So I'm creating a library, create series of books. I'm putting all the pointers of the libraries in an array of 4 pointers of library. Therefore, the 4th one will be null because it's less. And the same thing with the book. 7 book pointers, and I put 6 of them, so the last one is null. Therefore, null terminated. Now I can actually pass those things to show. So when they are passed to show, I'll go with the first one only. So it comes in here. Now this is an array of libraries. So it goes over there, prints library list, shows the library, and until there is no more libraries. That's it. Okay? Same thing happens with books. So shows all the books. Now I'm going to put these books inside the library of Vaughan. Put these books inside the library of Toronto and York. And now when I display, it tells me this is library list, this is library, books available are these. When I show the books, it does the exact reverse, and you can remove and show it. So I want you to go through this and tell me, what do we have? Is this an association, aggregation, or composition, and why? So reflect on that after you walk through it. And that's it. Questions? I want you to hack it. I want you to go through it and see how it works. Okay? It's a good practice. Nobody. Anyway. Are we good? Questions? Suggestions? Objections? All right. Now we are up to date with week 4. The next day you are coming over here. Questions, suggestions, anything you have, and you have a quiz. So we're going to do the quiz. After we do the quiz, if you have any questions, we do the questions. If not, we go home. Okay? All right. Have yourself a beautiful day, and we'll talk later. People at home, any questions? Are we good?
Yep, we're good.
All right. Have a good one, and I'll see you soon. Bye, everyone.
Thank you. Take care.
Thank you.
Thank you. Bye.